Hey, chemistry students, how you doing? How's this math? You getting a little confused? I hope not. Stick with it. You can do it. Hey, what I'm going to do here is I'm just going to run through lesson 5A, the example problems and the practice problems, and help you out in terms of looking at them and figuring out how to solve them. So let's see if I can go through this pretty quickly here. So lesson 5A, we're dealing with the Gay-Lussac law, and now we're dealing with changes in temperature and changes in pressure right there. So there's the setup. It looks a lot like Charles' law. When you have situations like this where they look like division problems, when you solve for any one of those, basically remember you're going to cross multiply and divide at the end. So Gay-Lussac, talking about pressure and temperature. I want you to use ATMs for pressure, and in all gas law problems, the temperature has to be in Kelvin, and it must be the same on both sides. So atmospheres, atmospheres, kelvins, kelvins when you're all done. Something that's going on here is add 273 to the degrees Celsius. Do that every time you see degrees Celsius. So, and always put a unit on your answer. They're always talking about the gas being held at a constant volume, and that's just because that plays another role in here, and we're just dealing with pressure and temperature. So here you go. Here's Gay-Lussac's law example problem number 1. And here's how I have it typed out right here. It's a little bit confusing, but these are already given to you. I've already been through it with you that I use the symbols P2. You can use X if you want. Just to remind you, here's the stuff that's given. Write it down on the left side, I suggest. And anytime you see degrees Celsius, okay, add that 273 to get your kelvins. Do that for both of them. Set it up. Here's your setup right here. And so then when you go to solve it, we're solving for P2. So you're going to cross multiply. So there it is, 516 times 3. And you're going to have 298 times P. You just do this. You don't have to carry that back over. Get P2 by itself. Cross multiply and divide. And it's actually more precise to do it this way. And then just type it into your calculator all at once. And when I do that, rather than rounding. And so the way I do that all the time, this is how I solve all these problems. I don't really do this every time and solve both sides. This is more precise, so I would just type in 516 times 3 divided by 298, and that's going to give me 5.194630872. And how many decimal places do we go? Well, in this one, I'm going to just go 2. So there it is right there, 5.19. Always put a unit on it. It's atmospheres. I'm a little bit off here, but I want to be consistent in general, and I try to put the number of decimals on every number that I want you to answer to 2 right there. So then I'm going to go on to the next one right here, and here's example 2. If we look at it right here, now you have to go through and read this, all right? So go through and look at it, and what do you see? First thing I see, I come across, ooh, there's a temperature. That's the first one. There's my first pressure. How do I know? ATMs, write them down over here. There's T1 and P1. Final pressure is, there's my P2, I've got it right there. Oh, it's in millimeters of mercury, just write it down. What is the final temperature? There it is. Immediately I see the Celsius right here, add 273 and get my 328. Millimeters of mercury, divide it by 760. You don't have to write this every time, but just to show you that those cancel. I'm going 2 decimal places on my answer, and I tried to be consistent here, and I was a little bit off right there. So I come over and I set it up. Again, you can skip this step right here and go directly to this. And really, all you have to show me is this setup right here. But students get confused a lot and bring things around in different directions. So if you just cross multiply those 2 and then divide by the one that's with the T2, you should get it right there. Okay, so you can skip that. And here I got 297.76. Example 3 right here, same thing. Now this one gives you extra information you don't need in the problem. But it's just telling you that if the volume changed, that would mess it up even more. And we're not going there. There are calculations for that. But anyway, so we're going to read across and look. Oh, P1, there it is. I already wrote these down for you. I know, but this is the hardest part, basically, is looking at it, writing it down, and converting it. So there I have my P1, and I don't have to worry about the volume. It wants a new pressure, so I already want P2. It told me those in a row, but then I have to keep reading. If it's increased, the temperature is increased from, there's T1, 67.8, and there's T2 98.7. So I'm going to add my 273 here, and I'm going to get my numbers there, and I'm just going to set it up again. There we go. That's the setup. That's all you really need to show, but cross multiply those two. So that times that, divide it by that. It's one less step carrying it around, and I'm going to get my answer at 6.21 atmospheres in P2. All right, so there's how I did that on number 3. Same. Okay, let's try the practice problems here. Now these take a little bit of reading. We know it's a Gay-Lussac, so we know we're going to have pressure and temperature here. So I read through and I see in my sentence, the first thing I see is temperature, 55.0 C, so that's T1. There's millimeters of mercury, that's P1. Calculate the new pressure, that's my P2 I'm trying to find. And it tells me the temperature, again, in Celsius, and that's going to be my T2. So I'm going to write that stuff down right here. And there it is. I'm going to make my conversions, all right? So my 1,778.40 divided by 760 gives me 2.34 atmospheres. I add 273, get 328 K. And I add 273 to my second temperature, right up here, 112.34, and I get 385.34 K. There's my setup right there. And so basically, I'm just going to bring this over, multiply those two together, and divide by 328. And I'm going to get my answer at 2.75. And make sure you put a unit on it like I almost didn't do. And those are in ATMs right there. I'm trying to be consistent and going 2 decimal places on everything. And I will tell you what I want you to do otherwise. So right here you can see what I had. I had 2.74907, so that brings that up to 2.75 at 2 decimal places. All right, let's do problem number 2. So when I look at this problem, it takes a little more reading, but I can see that when I read through it, I see that I have a pressure in millimeters of mercury, P1. Then I have a temperature in Celsius, that would be T1, asking me for the temperature of T2. And then I see a pressure in millimeters of mercury for my P2. So I'm going to have to make those conversions. So just to keep my numbers in mind right there. There we go. So here, I'm going to write them down. I'm going to take my millimeters of mercury, divide by 760, get 2.45, add 273, get 273 plus 0, and then divide and get 3.40. Here's my setup right there, atmospheres and kelvins right there, cross multiply, divide by 2.45. There's my answer there, 378.86, trying to keep everything at 2 decimal places. Here's how I got that. There's my answer, and I used the 7 to round the 5 up to a 6. So there you go. Hope that helps.